Alright, so today we're finishing 8.1. The thing we're going to talk about today are outliers. So an outlier is an extreme value. It's either much higher than or much lower than your other values. Okay, so there's a certain method we use to calculate these. And this also has a very strong effect on the standard deviation. Notice that it has a strong effect on the mean and the standard deviation. And remember, another word for mean is the what? Average. Okay, what it doesn't have a strong effect on is the median. Okay, so notice that even with our box and whiskers plots that we made, is the mean on the box and whiskers plot? Nope. So a lot of times people look at the average to, gauge a set of data, but sometimes it's actually the median that's a lot more valuable. Okay, so it's either much less than or much more than the other data values. So there's a certain method we use to determine outliers in a data set. This is something that you're going to need to be familiar with, not only the process, but explaining how the process works. I think I told you guys yesterday, there's like this joke that the higher in math you go, the less numbers there are, because they're more focused on explanations, different symbols. Okay, that's definitely true of stats, and we're going to be focusing on our explanations today. And we are going to be using the symbols that we learned yesterday as well. Okay, so to determine the outliers in a given set of data, we're looking for data values that are more than 3 standard deviations from the mean. So in yesterday's example, okay, if we go back, remember you guys found your mean and, I didn't have this one filled in, but you found your mean and your standard deviation. You wrote that down in your solution here, right? Can you guys flip over and look at that on your part? So what was our standard deviation there? What did you guys get for your standard deviation? Yeah, 4.78. Okay, and the mean was that 21.9 that I just showed you. Okay, so to find the outliers, you're going to multiply the standard deviation by 3. And you will need your calculators today, so make sure you have them. Okay, so then we're going to do 3 times 4.78. Okay, and we are going to be rounding to the nearest hundredth. And then remember that you guys have the PSAT and the SAT coming up, so make sure your calculators are charged, ready to go. And I told you yesterday, I'll tell you again today, I would have a backup scientific calculator to use. You can do all the problems without a calculator, but if you have an extra one, I can just bring it. Alright, and then once you find what 3 standard deviations are from the mean, you are going to add and subtract this number from the mean. Okay, so you're going to take your mean value, which is 21.9, and then you're going to add your standard deviation, and then you're going to subtract the standard deviation. Okay? So for this one, it was 14.34. That was your 3 standard deviations. see what we get. So we do 21.9 plus 14.34, we get 36.24. And we do 21.9 minus 14.34, we get 7.56. So what these mean are that any number that is above 36.24 is an outlier. So any number above this is an outlier. Okay, any number below this number is an outlier. Okay, so any number above when you add or below when you subtract, those are how you find the outliers. Okay, we can also represent that on a number line. Okay, and sometimes they will ask you to use a number line to explain what's happening here. So on the number line, what we're going to do is we're going to put the mean in the middle. So here's our symbol for the mean. And our mean in this case was 21.9. So based on our definition, anything that's more than 3 standard deviations from the mean is an outlier. We calculated those 3 standard deviations to be a value of 14.34. Now it doesn't matter how long or short you make this. I usually make it long enough that I can write on it. It just needs to be symmetric about both sides of the mean because you're adding and subtracting that value to each side. Okay? So when you add the 14.34, did I write something down wrong?
Oh, no.
Okay, go ahead.
Is this the interquartile range?
That. No, because the interquartile range is the median of the first half and the lower half, so those won't necessarily be the same. So when you add it, you get the 36.24. When you subtract, you get the 7.56. And then the number line is a great way to show that any number that's above that 36, that's going to be an outlier. Any number that is below this is an outlier. Okay, and like I said, sometimes they're going to ask you for a visual representation, which is why we're doing that. Okay, so you have your average in the middle. More than 3 standard deviations on either side is what we're finding. Okay, so you can use 3 standard deviations above or 3 standard deviations below. So if we're determining the outliers, let's look at the data from yesterday. We're looking for numbers that are above the 36.24 or below 7.56. So on yesterday's example, this is our data set here. You also have them written in your chart. Are there any numbers that are above 36 or below that 7? Nope. So that means in that data set from yesterday, there were no outliers in that data set. That was example 5. So no outliers, and I'm just going to put example 5. There's no numbers that are above this 36 or below this 7.56. Yep. So there's no numbers that are more than 3 standard deviations from the mean, which honestly, in a data set, that is a good thing. Okay, because if you have outliers, they are going to skew the data. So, for example, using my real life example, if people have taken a test and I have people that are absent, I'll put in zeros to remind them to make it up, but then the zeros bring your average down. So that would be a case when there are outliers, we want to either look at the median, or sometimes if I want to look at what the average is, I'll take out the zero so I can get a more accurate representation of how people did. Okay? Alright, so I'm going to show you something cool today. I mean, I know I show you something cool every day, but you're going to like this. So remember yesterday we found the mean and the standard deviation? You guys remember how we did that? We had to fill in this big chart. Wasn't so much fun, was it? Well, you're gonna really like how we're doing it today, and that's why you need your old graphing calculator, pal. So we're gonna find the mean and the standard deviation here for the heights of these 15 cans. Okay, so there are 15 cans, that's your total amount. If we were doing this like we did yesterday, we would add those all up, divide by 15. But today, I'm going to show you something on your calc. So we're also going to be identifying the outliers and describing how they affect the mean and the standard deviation. So something that's really big in statistics is explaining how those values either affect data or why they work a certain way. So explanations are going to be really important in this section and then on your upcoming quiz as well. So what we're going to do for this is find the mean and the standard deviation, and you can choose. You can do this by hand, okay? But I'm going to show you how to do this on your graphing calculator. So we're going to use something that we've done before. Remember how we used the stat and then enter, and we could edit list 1. Okay, so you're going to put in all the data values. Okay, and I'm going to give you time to do that right now. Okay, so we're going to go to stat, and then just go to enter, because we're going to edit. And then I have my list 1 in because I did this last chapter. But you can just put in your values from here. So there's 15 values total. Actually, I need to add one of mine in. Okay, so make sure that you guys have your 15 values in there. And then, do some of you need to borrow graphing calculators today? If you use the, just bring some of the trim.
Some of you, did some of you charge yours? Ashley, you got yours? You got yours?
It barely has any power left.
Okay. Do you want to use one of mine or no?
When it comes out.
Okay.
Do you need help with the data, or we're good with the input values? Alright, you guys ready to learn something fun? Yep, 3, yes, and then you're putting them all in L1.
So all of the parameters are in L1.
Yep, all those go in L1. Yep. So when we did it before with the regression, we had 2 values. We had an X and a Y, or we had 2 different variables, so we used L1 and L2. But for this one, where L1 is going to be where all of the data values go. Okay? And then what we're going to do is we're going to go to stat, arrow over to calc. So stat, arrow over to calc. And this is where we have been on the screen before. We were using the regression before, Now we're going to use this says one var stats, it's one variable statistics. Okay, that's what it stands for. So that's what we're going to use, the one variable statistics. So all you have to press is enter. And then different calculators have different menus here. Like sometimes you'll just have to press enter on the home screen. Mine, I have to go to calculate. And then look, what is this? What does this mean? Remember from yesterday? What's that? Yeah, the mean. Okay, so the mean is, what's the mean for this? Yes, and we will round to the nearest hundredths in this unit. For this one, if you guys rounded to the nearest tenth, because that's what those were, that would be fine. Okay, and then what else are we finding besides the mean? Yeah, so can you guys find where that is on here? Yep. See, it's right next to it. It just has an X next to it. Okay, so the standard deviation, so remember that's our lowercase sigma, is 0.19. Isn't that exciting and quick? Do you guys see what this is here? This says n equals 15. What's 15? Yeah, the total number of values, okay? So if for some reason you didn't get the same thing that I did and you saw your n value was different, you know that you were missing a value, okay? So you should have 15 total values put into your system, okay? All right, so now what we're gonna do is we're gonna identify the outliers. We're gonna use a number line to show our work, and then I'm gonna show you a new equation that you can use to check. Okay, so identify outliers. We're going to use the number line to show our work, and then I'm going to show you how you can check this. Alright, so in order to find the outliers, the first thing we have to do is what? How do we identify outliers? We don't need the median. So let's look back up here, right? So the outliers are more than 3 standard deviations from the mean. So we already know what the standard deviation is. What do we do with that? Times 3. Yeah? So we're going to multiply 3 times the standard deviation. Okay, so outliers are going to be more than 3 away from it, either above or below. Okay, so now let's look at our number line. And again, we're just going to put our mean in the middle. And then what we're doing with this 0.57 value is we are just adding that to this value here. And then we are subtracting it. And remember I said I don't care how long you make those, just as long as you are labeled. Okay, so just like we did before, we're just going to add and subtract. So we have 92.77 plus 0.57. And that's going to give us 93.34. And then we're going to subtract. Okay, so then what this means is any number that is above the 93.34 or below the 92.2, those are our outliers. Okay, so let's scour our data. Can we find an outlier? Is there an outlier? What?
92.
Okay, so 92.1 is less than the 92.2. Is there anything else? No. Okay, so that's going to be our outlier. And like I said, one thing on our test is explanations are going to be prevalent. So we're going to practice how to explain that. Okay, so identify any outliers. That is our outlier. Okay. So there will be something on your test where you have to explain it. So 92.1 is an outlier because it is this above or below the mean? Below. Okay, so it is more than 3 standard deviations below the mean. Sometimes it might be above, it just depends. Okay, but this is on the left side here. Okay, so we definitely need to understand these 3 standard deviations. That's important. Okay, that's how we're finding them. Okay, so now I'm going to show you how you can check. So if you have an outlier, okay, and you want to check, there's a special equation that you can use. I'm going to tell you what it is in words first, and then I'm going to show you the symbols. So what you do is you take the outlier value and you subtract the mean. And you take the absolute value of that entire quantity. So you take the outlier value, you subtract the mean, take the absolute value, which just means if it's the absolute value, it's distant, so it's the positive value. And then we're going to divide it by the standard deviation. Okay, so when you are in a statistics course, they would write it like this: x minus the mean divided by the standard deviation. Okay, so the x is just your value, whatever value you're using. This is our symbol for the mean. That's our symbol for the standard deviation. Okay? All right, so let's check it. So in the numerator, our outlier value is the 92.1. Our mean is the 92.77. Our standard deviation was 0.19. Okay, so we're going to do the 92.1 minus 92.77. Because it's the absolute value, I'm just going to take the positive value, the 0.67, and then divide it by 0.19. Okay, so let's look at our value. Can you guys think about the significance of this value? Yeah, exactly. So this is telling you how far away it is from the mean. So if it's above 3, you know it's greater than 3 standard deviations away. Okay? So if this value is greater than 3, which it is, we know it's more than 3. I put 3 times. You can write out times if you're going to think of that as x's. It's more than 3 times the standard deviation from the mean. Do you guys know why it has to be the absolute value? So remember how this is below the mean? Okay, so if you had the negative there, it's just because it's below. If it was positive, it means it's above. So you take the absolute value so you can compare it to the 3. Okay, now we did have an outlier here. So we said that the outlier is going to greatly impact the mean and the standard deviation. Let's see how much of an impact it has. So this is to remove the outlier. Okay, so we're going to remove the outlier and see what effect it has, and we're going to explain this effect on the mean and the standard deviation. So in order to do that, we're going to go back to our list. So go to Stat, Enter, and then find your outlier. It should be towards the end, the 92.1. I added mine at the end. And then just delete it. So just DEL is the delete. Okay, so then you should only have 14 values. So delete it from your data, and then we're just going to go back to Stat, arrow over to Calc, do the one variable stats, and let's see what our new values are. Okay, so the mean is 92.82. Okay, that's not a huge difference, okay, from our original. And let's look at the standard deviation. Okay, our standard deviation here is 0.08. Before it was 0.19. Okay, so that was cut by more than a half. That is a big change there. Okay, so for your explanation, you're just going to tell me what happened. So did the mean increase or decrease? Okay, we're inside. So the mean increased from 92.77 to 92.82. While the standard deviation, and if you guys want to abbreviate like I did, that's fine. This decreased from 0.19 to 0.08. So thinking about yesterday, when the standard deviation decreases, when it gets lower, what does that mean about our data? Yeah, it's what? Yeah, closer together. Great. Because the standard deviation tells you how spread apart something is. Okay, so this means that it's getting closer together at the central tendency. Okay, so at the median and your quartiles.